All right, hello once again, everyone. This is Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College online AWD or Application and Web Development 1100 C# programming class for the spring 2024 semester, I've been doing some videos basically based on the PowerPoint slides from our textbook for the class, that being Murock's C# 8th edition. I'm up to Chapter 8 of 22, How to Use Arrays and Collections. And our objectives, we've got two applied objectives here. Given the specs for an app that requires the use of a one-dimensional or rectangular array, write the associated code. Given the specifications for an app that requires one of the collection classes presented in this chapter, write the code that works with a collection. Now, what I did before we started was I wrote two different array apps. I did not write any apps that go over lists or dictionaries or anything else. I'm going to hit on that stuff a little bit later, just so you know. So our knowledge objectives, we've got 6 here. They are distinguished between a for loop and a for each loop. Explain how the array class can be used with an array. Describe how the null conditional operator works and when you would use it. Describe how you would use a list pattern to match the sequence of patterns against the elements in an array or list. Distinguish between untyped and typed collection class. And describe the difference between a list, a sorted list, a queue, a stack, and an array list. All right, and again, as I mentioned, I've been concentrating virtually solely in this chapter on going over arrays. I don't at all want to downplay the other ones because they're very, very important. All right. So if you take a look as they show on the slide here, slide number 4, you can create an array in 2 different ways. In the first one, you're using 2 statements. So you are declaring a decimal array named totals, all right, in the first line, and in the second line, you're initializing that array to hold 4 decimal values. All right. In the second one, you're doing it all in one statement. Now, why might you want to use 2 lines instead of 1? Well, perhaps up here, maybe this was instead of totals, maybe this was tests. And you wanted to ask in between these 2 lines, how many students are in the class? And if there's 25 students, you want a 25 there. And if there's 100 students, you want 100 there. That type of an example. Here's an array of strings. Now, unlike JavaScript, so those of you who were in the JavaScript class last semester, unlike JavaScript, the arrays in C# must all be of the same type. So these would be an array that would just hold decimals, an array that would just hold strings, etc. All right, so just so you're aware of that. Now, quite often when you're going to create an array, like I told you before, with 25 students or 100 students or whatever, quite often you'll come in and you'll create a constant that'll have the biggest size that you'll expect in the array. All right. Now, C# arrays are a different animal than JavaScript arrays. In JavaScript, you could create an array and not give it a size. In fact, you normally did that. And then you could fill up, let's say, the first 3 elements. Okay? And then you could say element 100 equals something, and the rest of those elements 4 through 99 would basically be undefined. Now, can you do the same thing in C#? The answer is kind of, sort of. All right, you have to take the array and basically make it as big as the number of elements you think that it'll have. When you declare an array, you have to give it a size. And the reason for that is what C# does is it puts that array in contiguous memory locations. All right, so it needs to know ahead of time how much space to put aside for the array. Now, here's some examples. So you could do this, all right, and then fill up each one. You'll notice that arrays, the first element in the array is element 0. Arrays are 0 based. They always start with element 0. So in the example they show here with totals, it would be totals 0, totals 1, totals 2, and totals 3, as are shown right there. Also, as mentioned in the comment, if you went in and tried to access totals 4, which doesn't exist, you'd get a special kind of an exception that's referred to as an array index out of bounds exception. All right. So here next we've got an array of strings. You can make an array of virtually any data type. If you know the values in advance, you can fill them up like this. Notice that when you fill them up, now I would recommend not doing this. Don't put a number in there or even a type. Just say decimal bracket totals equal and put this in there. The system will know that it's a decimal array and that it has 4 elements. So I wouldn't do it like this one. I would do it like this one. Same thing with strings. I would do it like this. Now, when you use var, as they show here, then what's happening is you're giving some power to the computer, so to speak. All right, because doing it like this, you're letting the system infer that the type of array is an int. I'm kind of at odds as to what exactly would be the advantage to doing that. All right, and there may be one. I just don't know off the top of my head what it is. All right, now they show a bad example in here. They show this decimal totals and then getting the sum. Rather than doing it like that with the sum, totals 0, totals 1, totals 2, and totals 3, which isn't bad when you've only got 4 values. What if you had 400 values? You really should use a loop in here like this. And I always, unlike what the author may or may not show, all right, when I'm doing this, where are we here? There we go. I always, always, always put my stuff in here in curly braces, even if it's only a single line like this. I still think it makes more sense to do that. All right, now as it says, that puts the numbers 0 through 9. Let's say you also wanted to get the sum of those numbers. Well, you could come in there and do int sum, whoops, try that again. Int sum equals 0. All right, that's got to be a little I, of course. And then here you'd say sum plus equals numbers sub I. And that's how you could figure out the sum. All right. Here's a loop that you could use to display all of the values that are in an array. Again, I would definitely come in and do this, and then come in again and do this, like that. I just think it makes much, much more sense to do that. If you don't agree, you're not going to do it anyway. I would never take off for you not doing it. All right. Now here's an average. So again, you could come in here and figure out the sum. And then divide. And notice what we're dividing by. Totals.length. That's how many elements are in the array. So if you've got 10 elements in the array, they're elements 0 through element 9, but that still is a total of 10. All right. A for loop for displaying some totals. Again, very similar to what I've already shown you. But as I already mentioned, I would be doing this. And I've had people in the past ask, it's like, why are you so whatever about this? To me, it just makes more sense. I like to know exactly what I'm doing in the body of the loop or in the if statement or whatever. All right. Now here's a for each, And I believe, I could be wrong here, but I don't think I am. I believe that in a for each, it only works with arrays. I know that some of these work with different types of collections. For each may work with things other than arrays. But notice what we're doing in here. All right, we're creating a local variable right inside of here. We're assuming we've already created an array named numbers. And we're going through and we're iterating over each one. So this says number string plus equal. All right, so there was nothing in it. So it'll have each number plus a blank space. And again, as always, there's other ways you can do this. Here's doing it, computing the average with a for each. Anything that you do with a for each, to my knowledge, you can do with a straight for loop. For each is more of a new-fangled concept in C#. All right. And I'm not going to say that there is an advantage to using or not using something. All right. A lot of it is what you are comfortable using, what you're experienced using, etc. And again, and I know I'm beating the same drum over and over again, and I get that, but that's okay as far as I'm concerned. All right. All right. Now, what they show right there is technically most books that I've read on the C# programming language will say that technically C# like JavaScript doesn't really have multi-dimension arrays. Instead, they have arrays of arrays. It really means they do have multi-arrays. Now, when you look at this, I'm going to leave this up here for a second, but I'm going to come in and type in Excel, which is going to start up an Excel session, and I'm going to bring up a blank workbook. All right, why am I doing this? I want to show you why I'm doing it. All right, if you're working in Excel, the first cell that you have in here is column A, row 1, or A1. When you're working with an array, so if this was a 4x4 array, so let's do this. There's a 4x4 array. So this in Excel would be A1, A2, A3, and A4. And the next one would be B1, and the next one would be C1, and the next one would be D1, etc. All right. In fact, let's just copy these. All right. Now, on the other hand, when you're working with a C# array, this would be 0, 0, 0, 1, 0, 2, 0, and 3, 0. And then this would be 0, 1, 1, 1, 1, 2, 1, and 3, 1. I think I can copy this now, but I'm not positive. There you go. So you can see the difference. When you are working in a language like Excel, it is column then row oriented. When you work in here, it is row then column oriented. This is row 0, column 0, row 0, column 1, etc. All right. And they give you a bunch of examples and they show you how you can set this up. If you want, again, notice that you put each thing together. So this is a 3x2. So there would be 3 rows and each row would have 2 columns in it, etc. And there's different ways of doing it. They show you some of those in here. Now, when you were working with multi-dimension arrays, you might use things as they show here like get length. All right. When you have a rectangular array, it's kind of what I just shown you. You've got the same number of rows in each column. But I'm going to grab this and I'm going to copy this and I'm going to put it down here. Okay. Now I'm going to come down here and I'm going to put in 4, 0, 5, 0, 6, 0. And here I'm going to put 4, 1, 4, 2. Here I'm going to put in, that would be, wait, let's see. 1, 1, 2, 1, 3, 1. That'd be 4, 4, 1. And that would be 5, 1. All right. This would be 4, 2. All right. And I'm going to leave the last one the way it is. Now what you have, this is a valid array in C#, and it's known as a jagged array. You don't have the same number of rows, or the same number of columns, rather, in each row. Totally legit to do that. All right. And I think they'll talk about that in here in just a bit. But when you do have the same, they're called rectangular arrays. And they give you a bunch of examples in here. All right. Now, we talked about sort earlier. Sort by default is normally going to be used with numeric arrays. You can use it with a string array like they show right here. Nothing wrong with that. All right. Here's the binary search. Now, I did my binary search a little bit different than the way they did it here. All right. And I guess I could have done that like they did it here as well. All right. Array.binary search. You search for something. Let's go back. And I wouldn't normally do this because I'm kind of mixing what I'm doing here, but I'm going to go back to here and go back to my array one that I did. And this is the one I did for searching. All right. Search for array element like this. All right. And I did it like this, and I brought in something from Visual Studio. Didn't have to do it that way, evidently. All right. Let's come down here and try something just for the hell of it. All right. I'm going to change the name of this button, just the name of the button text. From search, I'm going to change it to VB search. And then I'm going to go and grab these two, and I'm going to unlock them and move them down and put another button in here. And I'm going to call this one BTN C# search. I don't know if it'll take the sharp. It doesn't. Okay, so I will call it BTN CSHARP search. All right, but on the text for the button, I'll call this C# search, like that. In fact, I don't want to do that. Let's put it by the. Can we do it by the sharp? I think we should be able to. Nope. Well, it did it there. That's fine. I don't think I've got. Do I have C in here anyplace? L U V X L. There's the C. There's an E, which I think I already have. M and R. I'm going to put this one by the V for the VB search. Nope, I'm already doing that. I'm already doing that with the average. All right, let's lock this and let's try doing a C# search. All right, so where I did this before, I'm going to move this up like I've been moving up all of the other ones. Okay, and this I called search for array element. I'm going to change this to VB search for array element. All right, and I'm going to call this one, I don't know if I can I put a sharp sign in there? C# search for array element. It doesn't like that. So let's put the word sharp in there. C# search for array element. And we had VB search for array elements in here someplace. There it is. So there, we're getting the error, of course, because it hasn't been written yet. So let's write that. Private void C# search for array element. Now let's try grabbing what's in the book here with a binary search. So we've got that, got that, got that. I'm going to try it like this. Copy. I don't know exactly how this works, so I'm kind of doing it off the top of my head here. And I'm going to do an array.binary search, and I'm going to search I still think I'm going to need to do it this way. I need to have something where I ask the user to provide a value. Well, I'm going to check copy. All right, and I'm going to check it for, let's do here, we'll say int value equals 0. I'm just making that up. So this will be value. All right, now let's see. And I'm not sure if I can do this, but I'm going to go and try it right now. And that is going to be, I got to get out to the internet. Message box with input field. Display a dialog box with a text input. That's, I think, what I want to do here. Well, they're telling you to use VB, and I don't want to. I could do it again using VB. That's what they're doing. Darn it! I thought there was a different way of doing it in here, but maybe I'm wrong. Can I add controls to a message box? Well, let's just do this. All right, I'm going to do the same thing I did before. And what I mean is, I'm going to grab everything like I did in here before. All right, and again, normally I wouldn't do it exactly like this because I'm, again, breaking that rule because I'm reusing a lot of code. All right. So let's see, this SV right here would be it. That's our search value. If index not equal to -1, I think this is how this works. I should be able to come in just like before and do a message box and say that it's in the array, else do a message box that says it is not in the array. And I don't know if this will work or not. I don't know if I'm doing it right or not, but I'm going to try it anyway. So File, Save All, run this. So I'm going to come in here now and try to put in a C# search. Let's search for 68. It is in the array, and it is. Let's try it again. And let's try 48, which is not in the array. And it says it is in the array. All right, so that isn't the way that you do it. All right, so let's look. And so this is C# binary search. I'm learning with you. I'm going to put in here docs.microsoft.com. And I'm going to put in here, I guess it's learn.microsoft.com, sorry, C# binary search method. Array binary search method. There it is. If the value is found, otherwise a negative number. The value is found and the value is less. Let's see. Here's an example. Binary search this for this. If it's less than 0, it's not found. Otherwise, it is found. All right, so let's try changing this to less than 0. That's the VB. We don't need this anymore. Oh, we don't need that. So if the number is less than 0, it is not in the array. Otherwise, it is in the array. So let's try it like that. All right. So C# search, 71 should be in there. It is. 72 should not be in there. And it says it's not. If I put in something out of range, how about non-numeric? Get the error message. If I put in something less than 1, if I put in something greater than 100, great. It all seems to be working. Now, just to quickly, and I mean quickly, show you, let's see. I can grab all of this stuff, this sorting, etc., everything that I've done. Let's see. I'm wondering if I can grab everything that I have here, everything up to the SV. Up to right there. So I'm gonna come in here and I'm gonna type in here first, int SV. That's gonna give me an error because I already have it. But I want to take all of this stuff right there, and I'm gonna do. Let's do it like this. I'm gonna copy this, then I'm gonna comment it out, and I'm gonna write a new method in here. Private void prepare for the search. All right, I'm going to put all that in there. All right, now it doesn't like this SV. I'm going to make SV. This is not a good practice, but I'm going to take SV and I'm going to make it global. right, int SV. And this is going to be my integer search value. All right. Now, I can probably do it without making it global, but I don't want to spend a year and a half doing this. So right here, SV. It looks like we'll have to give it a value. So I'm going to say equals 0. All right, so there you've got that. Now, where I came in here, and I just am writing this prepare for the search, I shouldn't have any errors in there now with SV. Good. So I've got prepare for the search, index. So I've come in here, results equal this, throw it into SV. SV. Search copy for SV. It is assigned. It's being assigned already in here. Oh, I didn't call the function yet. Prepare for the search. That should go away, that error. That should go away. Prepare for the search. Call it in here. Do this. Result equal this. Put it in SV. I don't know why I should have to do this again, but SV. Prepare for the search. I'm going to make this a bool. And if I had any problems in here, I'm going to return false. And if I get down to here, I'm going to return true. All right. So, bool keep going equal prepare for the search. If not, keep going. That means it returned false. I'm just going to return. So I don't know why it's not recognizing the SV, but I'm going to make it by saying SV equal int 32 dot parse of search value, which of course again it doesn't recognize. Lovely. That might be the problem. I don't need that. Let's see if this still works. I'm going to do a C# search for 41. It is in the array. Now I'm going to try 40. And it shouldn't be in the array. Good deal. All right. So, should be able to get rid of all this. And I've replaced that with this. All right. Copy that. I want to do the same thing up here with the VB search. So let's try let's try the C sharp first. 34, and it's there. 35, and it's not there. Now well, that should be VB search, but that's okay. So 34, and it's there, and 35, and it's not there. Great. Just did a little bit of code refactoring there, right before your very eyes. This has got to change, so it says VB. VB search. Okay. Am I using B right now? B, 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 B. No. So I'm going to make this right here for the VB search. I'm going to make that V. Like that. That's what I wanted to begin with. There we go. All right, let's make sure I didn't break it. So we will do a VB search for 43, which is there. We will do a VB search for 44, which is not there. We will do a C sharp search for 43, which is there. And we will do a C sharp for 44, which is not there. Good. Oh, and it looks like when I'm doing these, I'm going to have to... So when I call VB search for array element, which is down here, sort display, I want to clear the list box first. It is not clearing it. It is putting it in there twice. Yep, it is repeating it. So somehow I'm not. So prepare for the search, clear list box. That should be clearing it out. Sort it. Oh, I don't want to clear it there. I want to sort it and display it. Let's try that. $73. 74, 75, those are all working. 73, 74, 75. Those are all working. Everything's working. The only thing I'd like to change here is where I'm saying these searches. Prepare for the search. All right, I'm gonna pass a number in here. So if it is a C# search and we're calling prepare for the search, I'm going to pass in a 2. And if it's a VB, because I'm doing that one first, I am going to pass in, where are you? Median, VB search, a 1. All right, and then in here, I'm getting errors because it's not expecting a number. So I'm going to say int num. All right, so the title here will be equal to if num string title equals nothing. All right, num equal 1 if the number is equal 1 question mark no, this is title equal if the number is equal to 1, then the title will be VB search for array element, colon, otherwise it will be C# search for array element. Let's see if that works. VB search for array element. C# search for array element. And it's still working. Great. More refactoring. All right, let's go back, jump back into our code here. Oops, I'm at 42 minutes. I'd like to finish this up shortly. All right, 25 out of 63. So I showed you the binary search. All right, code that creates a reference to another array. When you do this, and you set one array equal to the other, I believe then they both now point to the same array. That's making a reference. All right. Copy all of the elements in an array. This is relatively new. All right. Using array.copy. It used to be that to make a copy, let's see, inches, centimeters, inches dot length. All right. I probably could go back and make changes in the one I did, because I just did a straight copy, and probably there's a better way of doing it than the way I did it. Here's copying all the elements. Here's copying some of the elements. All right. You can return an array. When you return an array, all right, if you pass in just an element, it's just basically it's just like working with a regular variable. But if you pass in an entire array, you've got to put the brackets in there. All right. You can return an entire array. Remember, you can only return one thing, but that one thing can be an array. All right. A null array is just that. It's an array that isn't set. It has nothing set to it. That's a way of clearing out an array of setting it equal to null. All right, but if you try to do something with it after it's been set to null, you'll get a null reference error. Unless you check it as they show here. Or you use the null condition operator, which will allow. Now look when you do this. All the places they've got question marks. String means its first initial can be null, but its initials question mark, 0 question mark, dot to upper. You put the question marks on both sides of the array element. All right. And that's saying, basically, it'll prevent a null reference if the person doesn't have a middle name. All right. Now they're going to, as it says here, the array that's used in the examples that follow, and you can see that it's an array of decimals. How to refer to an element from the end of the array. All right, with a thing 2, 0, 1, but that's 2 away from the end, right there. And there's other ways too. Now, this is kind of neat. You can play with ranges. All right, 0 dot dot 3 means the first 3 elements, which means elements 0, 1, and 2. All right, or you could do just the ending index there. 6 dot dot, well, if there's 7 elements, it's 6 through 7. So there's a lot of ways you can do this. Just the dot dot would give you everything. You can use these ranges in a for each loop as they show right here. Now, one thing about this, just so you know, quite often I've shown you several ways of doing the same thing. Sometimes 3, 4, 5 ways of doing the same thing. And when we're talking in class, there's a good chance I'm not going to show you all of these ways. I'm going to show you what I consider to be the most intuitive way. Now, for me, what's most intuitive to me and what's most intuitive to you might very well be two different things. I'm more old school because I learned a lot of this stuff years ago. So the stuff I show you might be more old school and less new school. All right. I mean, these list patterns, they're showing some stuff in here. It's expecting you've got all 4 of these. Well, that'd be true. All right. That is not true because there's no 300. That is not true because there's no 400. That is true because it'll basically, I think it replaces that with this. All right. And there's a lot of ways you can do this. Some of it is really ugly. I don't know what list patterns is exactly the best thing to be doing and working with when you're first starting. My opinion, for whatever my opinion is or is not worth. Switch expressions, we've looked at some of these earlier. This can just be very, 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 one more time, very confusing. All right, now we're going to break away from arrays and talk about collections. Notice the similarities. They both can store multiple elements, but arrays, look at the bottom bullet here. Arrays are fixed in size. Collections are variable in size. So if you need to grow or shrink a data structure, you don't want to use an array. You want to use some kind of a collection. Notice arrays are a C# language feature. Collections are a .NET class. Collection classes provide methods to perform operations that arrays do not. Things like add. Things like remove. All right, so there's some adds. Now, one thing about this, I believe that what this does is when you're working with a list, and if you give it a size, and if it gets up to that size, it'll automatically double. So you have 3. So let's say it was 6. It's 3. 1, 2, 3. Once you put in another one, it doubles to 6. 4, 5, 6. It doubles to 12. It'll automatically do that. So it always makes itself hold any number of elements that you put in. That's not what an array does. It's what a list will do. So lists are more, I don't even know the word I'd use, flexible, extensible than arrays are. We'll use both. Mostly in Chapter 8, if not totally in Chapter 8, we'll use arrays. But when we get to, for example, when we work with link and some of the other stuff later, we'll look at lists. Okay, I'll just leave it at that for now. Again, there's an insert, there's remove. So these are things that lists have These are things that lists have that arrays do not have. All right. And like I said, I just don't want to get too off on this. It's way, way easy, as the saying goes, to go down this rabbit hole and just get really, really confused. That's the last thing in the world I want to do with or to any one of you taking this class. All right. So I think I'm probably just about done here. So you can go back and take a look. Let me mention at the end here, let's talk about queues and stacks. All right. If it's the first day of class, let's imagine that it doesn't work like this, but let's pretend it does. So it's the first day of class. And the first thing let's pretend we're in a classroom. And the first thing I say to you is, okay, we've got a bookstore down the hall. Again, this isn't the way it really is, but we're pretending. All right, go down to the bookstore down the hall and get a book, the book for this class, Muroc C Sharp 8th edition. So you walk down there and there's 10 people in front of you. That means that 10 people will be served and then you will be served. If you're the last one there, the last one in will be the last one out, basically, right? You'll go in order. The first one in is the first one out. So it's what's called a FIFO structure. The first in is the first out. So again, and I don't even think I have to do this, but I will anyway. And that is, if there's 6 of you and person 1 comes in line, then 2, then 3, then 4, then 5, I forgot 4, then 6, person 1 gets done first, then person 2 will get served. When they're both done, 3 will get served, 4, 5, and 6. So this is a queue, and it is also called a FIFO structure. First in, first out. Now, on the other hand, if you look at and you think about this, I remember this from my days in high school. All right, that if there was a big stack of trays that the cafeteria person brought out, let's say there's 50 trays, and they put them on one of those containers, boom, they push them down. Now, the last tray that was put in is the first tray that comes out. So, when you're working with a stack, as opposed to a queue, it is a LIFO, which means the last in is the first out. That's the main difference between working with a stack and a queue. All right. You can have an array list, and I believe with an array list, it can change size because it's a list. All right. We'll talk about this stuff more in class, okay? So again, removing and adding elements to an array list. All right, that's really it for this chapter. Now, I'm going to come back tomorrow, and this will be what I'm going to be attempting to do. I don't know if I'll get it done or not get it done, but what I'm going to attempt to do tomorrow is go through and do lectures, etc., on chapters 9, 10, and 11. All right. Chapter 9 is working with dates and strings. Not terrible, not real long. Chapter 10 is on more skills working with forms and controls. 58, again, not terrible. Chapter 11 is on debugging. That's a very short chapter. Well, that's good. Let me open it up again then. File, 11. All right, so we will go through 9, then 10, then 11. That's what I would like to do. If I get that done, then my hope is on Thursday, and again, I'm pie in the sky here. All right, but my hope is if I can get that done, then on Thursday, close a few of these things because I don't need them anymore. All right. Then on Thursday, I can do 12, 13, and 14. If I can get that done, then Friday, I'd like to do 15 and 16. Saturday, I'd like to do 17 and 18, and these will take more time. You'll understand when we get there. But if I can do 19 and 20 on Monday and 20 and 22 on Tuesday, that would mean then when we start Wednesday, I'm done with all these lectures. All right, that's my hope. I don't know if I'm going to be able to fulfill that or not, but that's what I'm going to try to do. All right, I'll talk to you tomorrow, hopefully with 9, 10, and 11. See you then.